Active anchors promote three principal attributes, which are releasability, variable pitch, and all-terrain. So what does this mean and why does it matter? Now, anchors are a simple tool made to try to hold on to the infinite complexity of the ocean floor. That is, they need to deal with everything from very hard surfaces like rock right through to very soft ground like mud. A simple solution to a complex problem, not something you want to be considering as you head towards the rocks or drift out to sea. So, how do you best deal with the variation? Now, most people try to solve the problem by using different types of anchors specifically designed for the type of ground they're on, such as reef picks for rock and a Danforth type anchor for mud. Or they have a single plough or spade type anchor that will work on medium to hard ground. Yet all have their drawbacks, as most anchors tend to be lost to rocks, and it's difficult to get one that will hold in soft mud without being oversized. The basic physics of anchoring are that you're trying to focus load through a rope or chain onto a single point on rock, or spread the load over a surface in mud, and you want the anchor back. In short, you need a large flat surface with a point that digs in and holds, but won't get stuck. The challenges are, for an anchor to dig in, the point or toe of a fluke needs to be orientated correctly to allow load to be focused. Secondly, to generate maximum drag, the entire surface needs to be as square on to the direction of travel as possible. The problem is, if you increase the pitch of a fluke, less force is applied to the toe, so you risk not being able to get the anchor to set or bite in. Because it's easy to get an anchor stuck in hard ground, grapple anchors are often used, and flexible steel rods, strip ties, and sacrificial pins are employed to help release an anchor. Yet, steel rods bend with a similar amount of force, irrespective of the load direction. Strip ties mean leaving plastic in the ocean, and sacrificial pins fatigue over time, so can break when you least expect them to. Now, although there are no certainties when it comes to anchoring, the two things you can be sure of is that on hard ground, an anchor needs to be releasable. And the only way to improve stopping power in soft ground without increasing anchor size is by increasing fluke pitch. It's for these reasons that releasable, variable pitch anchors are the only anchors that deserve the term all-terrain. So, how does an active anchor work? Seeing a mechanism operate usually provides the quickest method of understanding, and that can't be done underground. The easiest way to show how these features work is on a test rig. But please be aware, this video is only intended to demonstrate how the anchors operate. A test rig can't account for the infinite variations of ocean conditions. Active anchors can be set to be releasable. So you may be thinking, will an active anchor release when I don't want it to? Now, for clarity, you can never be 100% sure you have a good hold with any anchor due to the variable nature of the sea floor. With that said, the reason active anchors don't release easily in normal operation is because most of the force on the flukes is directed backward toward the axle and not at the pivot shafts. In technical terms, the pivot links can't rotate because there is an imbalance of force on the axle that does not allow the flukes to rotate, so the anchor doesn't release. Now, to demonstrate, we have a DF400 active anchor set at 45 degrees to the pull point, which would equate to a scope of 1.4 to 1, which is a very steep scope. The vast majority of anchors will be pulled from the ground at this scope. As load is increased, you can see the flukes pushing back at the axle without the anchor releasing. However, when we change position to pull at 90 degrees or directly over the anchor, it releases very easily, as the load is then directed to the pivot links, which in turn flexes the spring and allows the over-center mechanism to work, and the anchor releases. The same over-center principle is used to keep vice grips in place. The only situation where there is a higher likelihood of release is when the fluke tips are the only part of the anchor engaged with the seabed, as the axle can pitch up, changing the angle of attack relative to the vessel and transferring more rotational force to the pivot links. It's for this reason that an active anchor has harder settings to allow you to hold on to hard ground. Now, if you want no possibility of release, simply move the collar to the base of the shank. With the collar all the way down, the pivot links can't rotate, so the anchor can't release. In the locked position, an active anchor works like any other static anchor. For anchors with a static pitch, if the ground does not suit the anchor, stopping power is severely limited. A variable pitch helps active anchors to bite in quicker and generate more drag due to the spring-loaded shank, which allows the flukes to pitch under load. It's this feature that makes active an all-terrain anchor. It allows the anchor to both be adjusted and adapt to bite in quicker in harder ground or pitch to create more resistance in softer ground. The real advantage of variable pitch comes into its own when adding a stop to the larger active anchors, because although you lose the release function that you may not want anyway, what the stop delivers is an anchor that works exceptionally well in soft mud, where most anchors are virtually useless. So how does it work? Well, with the stop in place, you can set the anchor to pitch with a greater or lesser force by moving the collar. To demonstrate, we have attached slings to the flukes of this DF 500. The slings then act like mud pushing on the surface of the flukes. As load is increased, you can see the flukes start to flex backward, increasing the surface area generating drag. If you're in very soft ground and you select the softest setting, the flukes start to pitch at around 40 kilos. In the middle setting, they will start to pitch at 80 kilos, and so on. So if you're in very soft ground and getting the anchor to bite in is not the problem, maximum holding power can be achieved quickly and easily. If all this seems to be a bit complicated, it doesn't need to be. It's not necessary to get over-focused on the settings. If the ground is soft and you're not holding, try a softer setting. If you're on rock and there's a big swell, you may want a harder setting. For most situations, however, or if you're just not sure, the middle setting is your best bet. The term all-terrain simply highlights that active anchors will work well in an extremely broad range of seabeds. The great thing is you won't be leaving strip ties in the water, and there's no need to rip up the seabed to get away. So your impact on the environment is reduced. If you have any thoughts or questions, please get in touch by sending us an email to info@activeanchors.com.au. Thanks for your time.